Right now, as you watch this, there are people climbing mountains that would kill you. Not because they trained harder, because they carry DNA from a species we forgot existed. This is the face that gave them that gift.
In 1933, a bridge worker in Harbin, China, pulled a skull from the mud of the Songhua River. It was enormous, the largest human skull ever found. For nearly 90 years, we didn't know what species it belonged to. Was it an ancient human? A Neanderthal cousin? Something else entirely? In 2024, we finally got our answer. Using cutting-edge protein analysis and forensic reconstruction, scientists have pieced together not just what this person looked like, but why their genes still course through the veins of millions today. This is the story of Homo longi, the dragon man, the human species we erased from history.
Today, over 14 million people live on the Tibetan Plateau. They thrive at altitudes where oxygen levels drop by 40%. Most humans arriving at these heights experience acute mountain sickness within hours, potentially fatal within days. But Tibetans, they live here, work here, raise children here. For decades, scientists couldn't explain why. Then, in 2014, researchers discovered something extraordinary. Tibetans carry a unique gene variant, EPAS1, that regulates oxygen use in low-altitude environments. This gene doesn't appear anywhere else in modern humans. It came from Denisovans. Between 40,000 and 50,000 years ago, our ancestors interbred with this mysterious species. The Denisovans vanished, but their DNA lived on. For years, we knew Denisovans existed only through fragments, a finger bone, a jawbone, scattered teeth, until the Harbin skull changed everything.
The year is 1933. Japanese occupation forces are constructing a bridge across the Songhua River in northeastern China. A Chinese laborer, his name lost to history, discovers something in the riverbed. A skull. Massive. Intact. Unlike anything he'd seen before.
Knowing the Japanese would confiscate any significant find, he makes a choice. He hides it. For the next 85 years, the skull remains hidden in a well, a family secret. The worker dies. The secret passes to his grandson. Finally, in 2018, the grandson donates the skull to Hebei Geo University. Researchers are stunned.
This isn't Homo sapiens. It isn't Neanderthal. The skull is far too large, nearly 9 inches long, the face far too broad. According to Dr. Qiang Ji, paleontologist at Hebei Geo University, the cranial capacity exceeds 1,420 milliliters. That's larger than the average modern human. The questions multiply. The skull is at least 146,000 years old. The individual was male, likely in his 50s. He lived in a forested floodplain, hunting large game, enduring harsh seasonal extremes. But what species was he? Initial theories suggested Homo erectus, or perhaps a late surviving archaic human. But the skull's features told a different story. The face was flat, the eye sockets massive and nearly square, the brow ridge thick but not protruding like Neanderthals. And then came the breakthrough. DNA degrades. In hot climates, it vanishes entirely after 10,000 years. But proteins last longer. In 2024, researchers applied proteomics, the analysis of ancient proteins, to a Denisovan jawbone discovered in Tibet's Baishiya Karst cave. This jaw had been found at 3,280 meters altitude. Using mass spectrometry, scientists extracted protein sequences and compared them to known hominins. The match was unmistakable. The Denisovan jawbone proteins matched the Harbin skull. According to Dr. Frido Welker, protein specialist, the protein evidence links the Harbin cranium directly to Denisovan remains. This is our most complete Denisovan specimen. They named the species Homo longi. Longi for the Longjiang region of Harbin. But in English, it translates to something more evocative: Dragon Man. With the skull finally identified, forensic artists could do what had never been possible before: reconstruct the face. Layer by layer, they rebuilt the muscle structure, the tissue depth, the contours of a face lost for 146,000 years. The face that emerges is striking. Broad, robust, the nose wide and flat, adapted for cold, dry climates. The jaw massive but not protruding, the eyes set deep beneath prominent brows. This is not the caveman of popular imagination. This is a human being. Different skeletal structure, different adaptations, but human. He lived in social groups, used stone tools, controlled fire. He buried his dead. And when Homo sapiens moved into his territory 50,000 years ago, we didn't just compete, we interbred. That EPAS1 gene, the one allowing Tibetans to thrive at altitude, it didn't evolve in Homo sapiens. It came from them. Denisovans had already adapted to life in the thin air of the Tibetan plateau for tens of thousands of years. When we met them, we inherited that gift. Today, Tibetans and Sherpa aren't just tough, they're carrying the evolutionary legacy of an entire species. But it's not just Tibetans. Melanesians carry Denisovan DNA affecting immune function. Southeast Asians carry genes improving fat metabolism. We didn't erase the Denisovans, we absorbed them. Look at this face. 146,000 years separate us. Different species, different world. But if you met him on a mountainside, would you see a primitive? Or would you see what scientists now see? A fellow human, simply adapted differently. The Denisovans are gone, but they never truly vanished. They're in us, in our genes, our adaptations, our survival. Every time a Tibetan child climbs a mountain without gasping for breath, the Dragon Man breathes again. What other extinct species might live on in us? Share your thoughts below. And if you want to explore more mysteries at the edge of human evolution, like, subscribe, and turn on the notification.